This is Philosophy 6 at Las Positas College. We're working through an example of the Hurley Mindtap assignments from section 6.4. So if you completed section 6.3, you already know how to do the basics of truth tables. For section 6.3, you were looking at specific compound truth claims, and then you were asking yourself, what is the value of this compound truth claim for each potential value of the individual sentence letters? Now with truth tables for arguments, we're doing something a little bit different, but actually very similar. So here we have the argument given to us. Premise 1, if not J, then not D. Premise 2, it's not the case that not D and J, and conclusion, not D. So these are also indicated down here. So we have premise 1, premise 2, and conclusion. So premise 1, if not J, then not D, and this little dash right here indicates that premise 1 is over. Premise 2 is given here, and this double dash indicates that the last premise has occurred and the conclusion is about to come. Now our goal here is to test these arguments for validity. You recall that if an argument form is valid, there's no case, in other words, none of these lines will turn out where the premises are true, yet the conclusion is false. If it does turn out that for any of these lines, the premises turn out to be true, and yet the conclusion is false, that will mean that this is an invalid argument, and Hurley is going to ask you here to check a box if any of these lines show that the argument is invalid. Again, just thinking through this conceptually, a valid argument is one that the premises guarantee the truth of the conclusion. So if it's possible for the premises to be true and the conclusion false, that argument form is not a valid argument form. Just like with our last set of truth tables, all the potential values for both J and D are given to the left here, and then it's our job to fill these in and to solve the truth table. You already know how to do this, so I probably don't need to show you that process of solving it, but I will go back when we're done solving it to show you how I can determine whether or not the argument form is valid. If you need a little bit more review going over how to solve these truth tables, just go back to the example that you saw in 6.3, and that will walk you through the process. As you know, the first thing I'm going to do is just to go through and find the sentence letters and fill in from this left-hand column here for each of these rows the relevant value of the sentence letter into that row within the column. J is here and D is here. Okay, so I've filled in under the sentence letters. Now I'm going to reduce each of these premises as well as the conclusion. I'm kind of going to just treat them as their own individual complex propositions for which I need to know the overall truth value. So starting over here, I can start to analyze these, and here we have two cases where we have a tilde next to a sentence letter, so I know I'm going to start with those, and then after that I'll go on to take a look at this if-then, and for this premise at least, this if-then is going to be my main connective. So this is the line I'm going to worry about, ultimately for this premise. Looking at premise 2, we'll have two negations here that we're going to deal with, and then my main connective is going to be this tilde because it is outside of everything within these parentheses. For the conclusion, I only have one operation to do, so it's just a tilde or a not sign, so each one of these is just going to be transformed to the opposite of what it is right now. So I'll go ahead and fill these in, and then we'll see where to go from there. So maybe I'll spend a little bit of time here just to go through the order of operations and solving for a single row. So for premise 1, we started by filling in our sentence letters from the column over here on the left. Once we did that, we worked on the tilde for both of these, so the true became false and the true became false. Once we had that, we worked on our if-then. If false, then false, and that's going to be true. Remember that an if-then is only false when the antecedent is true and the consequent is false. So let's work on the same line for premise 2 here. First, we filled in our sentence letters. And starting from the inside here, we saw that D is not D. So the first not turns the truth value of D as true to D as false. The second not, it's not false, turns that back again to being true. And then we have true and true connected by the and. If both halves of a conjunct are true, then the compound statement itself is true. And then outside of all of these parentheses, we have this last negation. So even though everything inside the parentheses reduces to true, that gets reversed back to being false. So the truth value for this premise as a whole, when both D and J are true, is false. Nice and simple here for the conclusion. We started with D is true. That was negated. And so now the conclusion is false. So you remember now I'm checking for validity, which means I'm going to look under my main connective for premise 1. I'm going to look under my main connective for premise 2 and my main connective for the conclusion. And if it turns out that for any of these rows, premise 1 is true, premise 2 is true, but the conclusion is false, then I'm going to mark that because it shows that the argument as a whole is invalid. It can have true premises and a false conclusion, which means its argument form isn't a valid argument form, because in a valid argument form, the truth of the premises always guarantees the truth of the conclusion, or if the premises are true, the conclusion must follow. So let's take a look at the line that we just looked at. Premise 1 is true, premise 2 is false, and the conclusion is false, which means this has no implications for validity because one of the premises is false. What about in row 2 here? Premise 1 is true, premise 2 is true, so if the conclusion is false, that means the argument is invalid, but it's not. The conclusion is true. For line 3, a premise is false, which means automatically it has no effect on validity because the premises aren't all true. Here again we have true premises, but we have a true conclusion, which means that none of these 4 lines show the argument to be invalid, and therefore it is a valid argument. So based on the completed truth table, the argument is valid. Let's see how we did. And it looks like this time we got them all right. Good job, everybody. So I hope this example is useful for you, and good luck on the assignment.